Hello, this is Robert Guderian, and today we are moving on with strings and I/O into the I/O part, which, as you may or may not remember, stands for input, output. So you've seen output, you've printed, but we haven't seen the I. How do we do input? Well, guess what? It's the input command. So it's actually fairly easy. And the beautiful thing is that it comes in as a string. And it does that because strings are a very flexible data type. A string can hold a number, an integer number. It can hold a floating point number. It can hold a book. It can hold binary ones and zeros. It can hold basically anything, especially anything that comes in from a keyboard. Like you're looking at the keyboard, like all that stuff. Yeah, that's all just characters, right? So it can capture all of that. So how do we do it? Well, spoilers. It is just input. So we could look at the Python built-in functions. So I could just say Python built-in functions, and it will be here for us. And it's not a bad idea to look at the documentation because it'll tell us everything we need to know. Sometimes not in a way that we want to read it. Sometimes it'll be very arcane in the way it's written. And you can find out just how fast Farmer Internet is. Awesome. Well, what we need to know for now, at least, is that we can pass it a string. And that string is a prompt. So this is important to us because we'll be asking questions from our users, and they have to know what the question is. I'm going to name this input, and I will enhance. So the key here is the result goes here, and input, and this is a function, it's a built-in function. I'm going to jump over to this so you can see what it's prompting me right now. Prompt : any ... / stir. So that arrow here results in a string. Read a string from standard input. Trailing new line is stripped, where the string prompt, if given, is printed to the standard output without the new line before the new input. Okay, well. Wow, this page is still loading. Oh dear. Farmer Internet. That's okay. I think it's the exact same text that's in the documentation. I just wanted to prove it to you. So I'm going to say, can you type the letter A? And if I save this and run it, it'll literally say, can you type the letter A? And I'll be like, donde esta? Notice that there's no space here right now, and that's kind of ugly, and I don't really like it. Now, what is in the result? Donde esta? Cool. All right, good. We win. Lecture over. Go home. Well, what about this? Print. I want to add two things. A plus B. ... Whoops. Then A is equal to input. I type that a lot. What is A? I'm going to put a space and an arrow, which makes for a really nice prompt. And then another space after that. And then copy and paste because I'm lazy. And if you are lazy, you might like computer science. Come to the dark side. We have cookies. And B. Then I'm going to say, okay, print A plus B. So, can you type the letter A? No. What is A? 3. What is B? 6. 36. 3 plus 6 is 36. This is called a runtime error. When you have bad syntax, that's called a compile time error, loosely. And if you run it, it'll come up as a syntax error, saying, hey, yeah, that's not a thing. I can't do it. But a runtime error is more subtle. And this is because your program still runs. Sometimes it'll crash halfway through, but this is functioning code. The cartoon for the class above is do what I want you to do, not what I told you to do. This is the kind of thing that that cartoon is talking about. So this is literally adding the string A to this string B, and 3 and 6 is appended to 36. So it doesn't do the math, it's doing string appending. And then we can say times 10. No. What is A? 55, B, 44. Yeah. Python, man. It's great. Come on down. Yeah, it's multiplying will actually just give you that letter or that string that many times. So I had 10 33s. Why is that a feature? I hate it. No, I love Python. It's finicky. Okay, so we have a problem. Getting input is easy, but it comes in as a string. Very important that we know that it's a string. And this is the same bug. So what we need to do is something called casting. We need to change the data type from a string into a numeric type so it can do math on it. So there are other built-in functions, and maybe I can even show you that page. So yeah, we have input. I'd click on the link, but I'm worried that it'd reload the page and it'd take forever. Oh dear. There we go. Input, prompt. That's not quite the same text. That's interesting. There's lots of Monty Python references here. And I am guilty of using them too. So we can cast to an int or a float, and that will force our data type from a string into an int or float. That is the key of what we're doing right now. I will do that on the side here first to prove to myself that it works. So I can even use A. So I can say int A is going to be the number 55. And how do I know it's the number 55? Use type. Number? I want to put a question mark here, but that doesn't work as a valid variable name. Int A. So type of number is an int. So that means I can actually add 1 to a number, and it'll be 56. And if I do that again and again, it'll always be 56. It's not trying to append a string, which is good. That's what I want. That's exactly what I want, what I really, really want. So what I'm going to do is say integer A is equal to int A. Integer B is equal to int B. Then I'll have to change these. Well, I'm actually going to leave that because I think it's funny. Why did I copy and paste that? I could have typed that faster. There we go. So I will, of course, get 2 different results. Can you type the letter A? A. And what is A? What's math I can do in my head? 6 plus 4. 64. No, 10. Yes. So changing the data type is very important. But one of the problems is that our users are irresponsible monkeys at keyboards. So what is A? The letter A. What is B? B's. Invalid literal int with base 10, the letter A. So I tried to cast not a number to an integer. Well, that doesn't work. And you can see that it gives us the line of code that failed here, and gives us the line of code that failed here too. In this case, it even gives us the line number, and I can click on it, and it'll bring me over there and say, yeah, this is the line of code that died. And it's because invalid literal for int with base 10, the letter A. Invalid literal being the literal meaning, you can't cast these letters and numbers to a number, so it fails. This is called an exception or an error. So this is another runtime exception. This time it actually halted the running of our program at this line, at line 8, because it can't do that. It is impossible for it to run that line of code. So it stops. You could call this a crash. Arguably it is, arguably it's not, but I would be fine if you called it that. So there's a shorthand that I do not like, but you may see, and I want to just show you it so you can see it in a safe place. What some people like to do, I disapprove of, is this. Input is equal to, oh, no, that turned purple. That would be me overwriting the word input. Data is equal to int input, give me a number. And then I'm going to say arrow, 2 functions. So there's 2 functions nested. So it's going to run the functions from the outside in. And I want to show you what I mean by that. So I'm going to say n is equal to int input word. So that's our prompt. Oop. That's our prompt. What's going to happen, it's going to run this inside out. It needs to resolve this first. So that it can be passed to int So it's going to run my input first. It's going to ask me for input and then pass whatever my result is to the int method. And then that int method, that will all get stored to n finally at the end. And that isn't order of executions. If you look at brackets, mathematically, that's what you should do. So this all still kind of works with math, which is very good. And what could possibly go wrong? Well, what if somebody puts the letter A as a result here? Then you try to cast A into an int and then it dies. We don't want our programs to crash. I find this unreliable. And unreliable code is crappy code. One of the goals of this course is that you don't write crappy code. So therefore, this is a bad idea. In next week's lab, I believe, once we learn about loops, we're going to show you how to get input properly, reliably, and correctly. And that's important to me, and that means that it'll probably be on some kind of test. I really don't like crappy code. I really, really don't. So that's really it for input. We do want to get it reliably. We don't know how to do that yet. At this point, we'll just believe that users are reliable. Terrible assumption. But for now, that'll work for us. So I'm looking forward to teaching you about loops and how to get reliable input and do cool things with input. Until then, I'll talk to you later.